So my name is Jimmy. You can find me at Twitter at @jbogard. The presentation and pretty much anything I do you can find on my GitHub, github.com/jbogard. And I blog on jimmybogard.com. I also had a whole bunch of blog posts still sitting around the site that is sometimes up on thosetechies.com. Most people know me from some open source libraries, of which I'm deeply sorry if you are having to use them today. If you like them, then you're welcome. Thank you for using them. Appreciate it. So this is a story working with my developers about a year ago or so, where I had a developer come up to me and say, this is for an e-commerce website, for the checkout page of this website. They said, Jimmy, I think there's something wrong with these lines of code, but I don't really know for sure. Can you come take a look? So I took a look at those six very small little lines of innocuous code and said, yes, you got something really wrong on your hands here. Good job for pointing it out. And so let's talk through ways in which we can fix these 6 little lines of code. Now these are lines of code that probably anyone here has written. I know I've written them myself as well. They look something like this, these 6 little lines of code. It starts out pretty simple. This is for the page, or the code that whenever you click checkout, it takes your money and does all sorts of crazy things behind the scenes. It starts out pretty simple. First, I'm going to take your card information and find the customer from the database. Right? So far, so good. Then I'm going to take that information from your customer and the cart and build out a cart object and build out the order based on your cart details and your customer information. All right? So far, so good. Nothing going wrong here. The next thing we do is we go ahead and post a payment to the Stripe API. Stripe has a really nice .NET library. They just released actually this week. Excuse me. And so they go ahead and post that payment to the API via Stripe. Now, once that's successful, because it's always successful, of course, we go ahead and then send you a thank you email to SendGrid, because that also has a nice little API. And finally, there are some downstream systems and downstream people we need to notify. So we go ahead and use RabbitMQ to publish the message to the bus. And then finally, because everything's good, everything succeeded, we go ahead and show that nice little thank you page. And around all of this, in some kind of like action filter or something like that, is a transaction that says, go ahead and save the changes once everything is successful. Now, this set of code assumes that everything always goes well, that nothing ever fails. So the developer came to me and said, I think something's wrong because we're assuming that everything succeeds all the time, and we don't have any code that says what happens, not if something fails, but when something fails. And one of the things I always have in the back of my head when I'm building distributed systems is failure is always an option when building these kind of things. We have a reasonable understanding and idea that the application that we build is going to be up and running. We hope that the database is always up, right? Your databases never go down, right? No, of course not, never. But those other systems that we're talking to, Stripe and SendGrid and RabbitMQ, those are the ones that we have a lot less control on, a lot less control over, and we can't make those sort of guarantees that says those different third-party providers are always going to be up. For me, I try, of course, to make my systems up as much as possible, but we don't have just unlimited money to make sure everything's up all the time. And in fact, because Google can't even keep Gmail up 100% of the time, if they can't do it, then really what hope do we have for the rest of us? Like none whatsoever. So in building systems like this, I try to design them and build them in such a way that I assume failure is going to happen. So the developer and I sat down and said, OK, let's walk through these options. Like, how bad can it get if something goes wrong here? And so we looked at all the different things that 6 little lines of code touched and said, OK, for each line of code, what happens, not if something goes wrong, but when something goes wrong? So those 6 little lines of code are represented by this diagram, where first we had that call to the database, a couple calls actually, to go ahead and load up the customer information and create an order. Then we called a set of third-party providers. And then the last step down here was to then commit that entire transaction. So let's walk through each of these steps and say, what happens when that call fails, when something goes wrong there? So the first thing that can go wrong is that first call to the database, where I say, go ahead and give me the customer information and build an order based on their carts. What happens when that fails? Well, nothing too bad. I mean, the customer that's submitting the order might see some screen that says, something went wrong, please submit your transaction again, which of course no one ever does, right? Because I put the credit card in there, and I don't trust you to not charge my card twice. But from a system perspective, the transaction rolls back, and then the entire system is consistent, so everything's good. All right, so what happens when that Stripe API call fails? When the Stripe API call fails, it's actually not too bad. No money posts to the Stripe API, that is, I don't actually take money from the customer. The transaction rolls back because there was an exception, and then the system is consistent. Still not too bad. The next one is where things really start to go wrong. What happens when SendGrid fails, that email service provider? Has anyone had their email service provider go down for like a day? Yes, that has definitely happened to me. And we'll ask them like, hey guys, what happened to your API? It's down for a day. Oh, it's just some unplanned maintenance. Oh, thanks, appreciate that. Heads up there. So when this call fails, what's happened? We've already posted the payment to Stripe, but the transaction rolls back. So we've taken their money, but have no record of doing so. That's probably not a good spot. This is where people start calling you and complaining, and your manager starts yelling at you like, why are you taking people's money without, although maybe the revenue numbers look good, right? Like, like business is doing well, just everyone hates us. So at this point, the system is inconsistent, things are messed up. The next one, RabbitMQ going down. Now this is one of those things, again, that I don't find that I have to put a lot of assumptions in my system to say, if my message broker goes down, usually there's something really wrong with my system. But these kind of brokers aren't always able to be deployed in a highly available manner. Especially RabbitMQ, that's actually very difficult to get it to work correctly and deployed in that manner. And it's also on the default mode of working, because by default you just do like file install and you assume everything's up. But to actually get it to do this highly available mode, you have to have I think you have to actually pay for it. It's not even free. So what happens if that goes down? This is even worse. We've actually charged the customer via Stripe. We've told them about it via email, but the database transaction rolls back because of the exception, so we have no record of this actually ever happening. Again, not a great spot. Maybe our revenue numbers look great, but they probably eventually go down because, hey, we're not actually shipping anything to our customers. Now the last one. This is where things can really, really, really go wrong. What happens when that final database transaction commit fails? Well, first of all, we may make the assumption that says, okay, if we've already been able to contact the database to begin with, I mean, what's the likelihood of that transaction failing at the very end? Well, there's a lot of things that can go wrong. Things like constraint violations. Those are not actually evaluated until you commit the transaction. Even just a network hiccup, something going wrong, or someone pulling the plug on the server, because that can happen, right? It's like accidentally turn the server off, that happens. So it doesn't even matter like why that could possibly fail. We have to think about what happens when that fails. Well, we've already called Stripe, so we've charged the customer. We've also notified them via an email to say, hey, thank you for your order, it'll be shipped to you soon. And we've also notified downstream systems to say, hey, there's an order that's came in, go ahead and do your processing, go ahead and ship it out. But because the transaction rolled back from the database, we have no record of any of those kind of things ever happening, except probably log files. That's our last refuge, is something, the customer complains, they said they didn't get their order, what went wrong? Let's go troll through all the little log files and see what the heck went wrong. And everyone has semantic logging here, right? They're able to completely reproduce any kind of production action that's happened, right? Everyone has that in place all the time? All the time? Oh yeah, everything's, yeah, exactly. No, we don't always have that in place. We can't just reproduce any kind of customer action. On top of that, we may not even have all the details. Things like the customer's credit card number. We probably don't log that, right? Probably, hopefully, yes. So we have the situation where all these downstream things have happened, both from the customer perspective and our own internal downstream system, but the system is just completely hosed at this point. It doesn't have any knowledge of these things happening except for an angry customer and some log files, and maybe even just the log files. So this is what was shown to me about a year ago or so. So I had all these things that could possibly go wrong. Something looks fishy, but now we have to decide what do we do based on all these different failures. Well, the current choice we had in that system was just whatever. Let's just assume that everything's okay, and if something goes wrong, then we'll just send a sorry email, something like that. But for most businesses that I work with, especially ones that actually take money from customers, which I think is probably the vast majority of businesses, I don't know any ones that don't actually take money, just throwing up your hand, shrugging your shoulders, and saying, that's probably not too good for business. That's probably one of the things that you end up on a Troy Hunt presentation sometime later about how much you've screwed things up. So we can't just throw up our hands. And in fact, the business probably doesn't even know that we've done this. We've made this choice. Maybe we've not made this choice explicitly, but in our code, those 6 little lines of code mean implicitly that we've just kind of given up here. So going back to our picture, in an ideal world, if there were no laws of physics or anything like that, we could put this entire operation in a transaction. So that the entire set of steps, everything on the screen, either succeeds or fails. If it fails, then everything rolls back. If it succeeds, then everything goes through and everyone's happy. But we can't put the entire world in a transaction. I know, I've tried. Have anyone used the WS transactions, the web service thing? That worked swimmingly, didn't it? So anyone here ever used a distributed transaction coordinator, the MSDTC? Yeah. Your operations people love that, I know. It never goes down. So we can't just put everything that we use inside this one single transaction. Even if it's possible, that makes the entire operation go really, really slow. And in fact, a lot of our measurements show at least an order of magnitude, if not several orders of magnitude, in performance drop whenever we try to put everything that we have inside a single transaction. But we have these third-party APIs that don't support this kind of transactional behavior, nor I don't think they ever want to. So we can't put everything we have in a transaction. That's just not an option for us. So what we have to do is assume that any one of those things failed. And then, based on that assumption, then decide, OK, what should we do from there? If we plan for the worst thing that could possibly happen, then it should put us in a good final end spot. Now, when I'm looking at evaluating, OK, we want to do something based on each of these things possibly going wrong, we have to evaluate a few options based on what is available in those different providers to do based on failures, as well as what means the most sense based on our business about what each failure option would satisfy their business goals. Now, luckily, I didn't have to come up with any of this stuff. All this failure mode, failure options has already been put out there. And so the ones I was looking at was a paper from Gregor Hope. This one is, your coffee shop doesn't use two-phase commit. And it describes what can happen in a real-world process when things fail, and what are the different options we have for dealing with that failure. This paper used to be called Starbucks doesn't use two-phase commit, but I think Starbucks caught on to that and said, we don't want to be in your failure paper. So now it's just your coffee shop doesn't use two-phase commit. Now in this paper, it describes trying to coordinate activities between 2 different resources and one failing, and what to do when that other resource fails, whatever options to be able to deal with that failure. Now the first option we have when we have 2 resources we're trying to coordinate in an activity, and the second one fails, is simply to ignore the other failure and just keep on going. Now, from a business perspective, this might seem a little weird to say we would just ignore a failure and go on with our lives. But in reality, in the real world, we do have this kind of situation come up quite frequently, where we're trying to coordinate 2 activities, something fails, and we say, well, maybe that other thing wasn't that important. Maybe we can just keep on doing what we were doing before. In highly available systems, ignore is a really good option to look at to make sure that we can still have high throughput and not try to put the entire world in a single coordinated action. Most businesses I know don't really like this option of just ignoring failures, so this may not actually come up in real life a whole lot in our systems. Now, the second option we could look at is a retry. When the second action fails, we can just try that second action again. Now, this can present some problems for us. Not every single action is retryable. And for that second action, we may not be able to retry indefinitely. We probably don't want to just keep trying this action till the end of time. So there has to be some logic about when should we stop trying to do this other action, and can that other action even be retried in the first place? Our third option is an undo. So in this case, we're not going to try the second option again. We're going to have an undo or compensating action for that first thing that happens. This again assumes that the first action is undoable in the first place. Maybe that's not a transaction kind of thing. Maybe there's an actual compensating action we can do. Something like, I've turned the lights on. The compensating action would be to turn the lights back off again. Now the final one that we have available for us is this coordinated activity. This doesn't necessarily assume that we have a transaction available between two resources. But what we can do is design a protocol that says, I'll have a multi-step process to coordinate these two things succeeding or failing. And it'll always involve a third-party coordinator to ensure that these things happen. So the first step in this protocol is to first ask each resource to prepare a transaction. Now, if anyone here has ever bought a home, that escrow or mortgage agent is serving as this coordinator. They sit you down in a room and say, okay, do you have that either cashier's check or something that says, I have the deposit for the house? Yes, you verify you have the deposit. They don't take it from you right then. They just make sure that you have it. Then they go to the seller and they say, okay, they have the deposit. Is the final price okay with you? You're good to sell. And hopefully they don't back out of it, because that's happened to me and that's a horrible feeling. But hopefully they say, yes, we still want to sell the house for this amount and this agreed upon date. And now that we have both parties agreeing that they intend to do this transaction, now we go back to each party and say, okay, let's go ahead and commit this transaction that we're doing. So I'll go ahead and take the money from the person, and I cry a little bit for all that money I just handed over. And for the seller side, then they go ahead and sign over that deed and hand you the keys. And facilitating all this is this coordinator that we have, this mortgage agent, this escrow agent, something like that. Now this is not a bulletproof protocol, because on that second phase of the transaction, the second phase of that commit, something could still get hiccuped there. So let's say I took the money from the person, from the one buying the house, and I go to ask the seller, okay, you good to go? And then they have second thoughts, or they just leave the country for whatever reason. I've taken the person's money, and maybe I've even cashed the check, but hopefully not. And the other one has failed and is no longer there. And so now I'm on this still in-between state. So I even have to have even more compensating actions to be able to roll those things back. Now in systems I work with that try to choose this option only really works when that coordinator is very close and highly available to the things it's trying to coordinate. The more I move that coordinator away from the things it's trying to coordinate, the more likely that this transaction is going to fail. So when you deploy this kind of environment, you have to put things very close to each other to make sure that they succeed most of the time. Now, you're not necessarily forced to use something like a distributed transaction coordinator for this kind of operation. As long as I have something that can do a similar kind of protocol, this is a valid choice for us. Now, I've gotten my 4 options for dealing with failure. My master plan here is to take each of those 4 options and evaluate it against each of the steps I had on those 6 little lines of code. And say for each of those options, 1, is this option for failure even a valid choice for us? Is it possible? And 2, what does it make sense in terms of the business transaction that we're trying to do here? It's still important here that we talk to the business to say, based on these options, what should we do here? Because the implications for failure and success still will be bubbled up all the way to the business. So I have to get them involved here. Hopefully not using terms like distributed transaction coordinator, because there's nothing that makes a product owner's eyes glaze over more quickly than starting to talk about DTC protocols. At least I hope you haven't done that. So for each of these external resources, examine each of the possibilities for dealing with failures and pick the best option based on the business requirements at hand. Sound good? OK. So the first up in our list of resources that could possibly fail is going to be Stripe. Now on the database side, because we saw that if that piece failed, the transaction would roll back and would be good to go, I'll go ahead and say, well, we could just use that normal database transaction and call it a day. But for the other third-party resources, let's go ahead and see what are those different options for us. So in our code here, just to remind you, we had that set of transaction code hitting our database, so we do control. And then after that database stuff, then we have this call to the Stripe API. So the first option looking at is to ignore. That is, wrap that Stripe call in a try catch, and if something fails, just keep going on and do the next set of steps. That probably doesn't make a lot of sense for us to just ignore a failed payment and then assume that we can go ahead and ship the thing to the customer. I assume we actually want to have a business that can take money from customers and stay in business over time. So just ignoring when failures and when payments fail is probably not a good thing for our business. So that's not one I would ever actually take to the business and say, hey, is it okay if we just don't take money from customers? Is that cool? I'd probably get laughed out of the room. So that's just thrown out the door immediately. The second option for us on Stripe is to retry. Now, before I think about the code implications or what this, if the Stripe API even supports it, we do have to think about what if that retry is even possible in our code. So in the Stripe API, basically what I'll do is I'll Google the name of the resource and then retries and see what pops up. Now, not every single operation is retryable. In the case of calling a Stripe API, if I call the API twice and I retry it, maybe the first one timed out, but I don't know if it actually succeeded or failed. I was waiting for a response and I never actually got it. Some failures are very quick, some failures are slower, and those slower failures, I can't necessarily make that assumption that it actually failed on the Stripe side. So what we don't want to have happen is to take the customer's money twice. Because almost worse than taking their money once and not telling about it is taking their money twice and double charging them. So if I want to be able to call some kind of resource multiple times and still have it as if it only had that operation happen once, there's a term for this, and it's called idempotency. Idempotency means I can do an operation multiple times and have the same end result. Idempotency is not a medical condition. It's an actual thing we can do with our systems. So what I'll do is I'll just Google resource name and idempotency. And what comes up? Stripe actually supports idempotent requests. Now the way they do this is they have to have some way of correlating a request if I make it multiple times. They can't just assume oh, you got this call from the same provider, from the same endpoint for the same amount within 5 seconds. That must be a duplicate. Well, they don't make that kind of assumption. So what they can do, though, is me have some way of saying, based on me calling your API multiple times, this represents one logical business transaction. And so they have this in the form of an idempotency key. I pass to them some kind of unique identifier that represents this business transaction. And on their side, if they receive that request more than once, they'll only charge that customer for that one initial call. Now, just because Stripe supports it doesn't mean we just start calling it with any kind of random data. We need to make sure that we pick something on our side for that idempotency key that represents that idempotent action. So what represents in our system the business transaction of someone trying to place an order? Well, it could be a cart ID. The cart ID represents that logical business transaction of me trying to place an order. So maybe we can just straight up use that as our idempotency key. Or if we don't have that, maybe we just make something else up, but something that logically represents me clicking that button and trying to place that order. And hopefully this kind of idempotency key I would want to store along with all the rest of my business data. But that seems like a logical thing we can do is say the cart represents me trying to place an order, so I will just pass the cart ID as that idempotency key. Now, nowhere pictured here do you have me actually retrying this operation. So we would still need to put some mechanism to be able to retry this. Maybe it's on the client side. When I click the button, I would check to see if the call failed or succeeded. And if it failed, I go ahead and just post the API call again. or maybe there's something in my server side that is detecting failures and then retrying this operation. Whatever it is, by me using Stripe API to be able to pass in an idempotency key, I can ensure that if I try to post this payment twice for the same cart, it will only charge the customer once. So our third option, we had ignore, which was not a good thing, retry. The third one is undo. Now, undo doesn't necessarily mean I have a rolled back like database transaction. It could also mean that there's some compensating action that I do. So for Stripe, what is a compensating action for charging a customer? Refund. Yes. So for this resource that I'm looking at, whatever it might be, I tried to Google what that compensating action could possibly be. And so in this case, Stripe with payments, an undo of a payment, a compensating action, would be a refund. And Stripe, thankfully, supports refunds directly out of the box. So what would this look like in our code? In our code, we put some kind of try-catch around the entire payment processing. And when something fails, I would check to see if I had a Stripe payment based on that Stripe payment object. And if that payment actually exists, then I'll go ahead and call the Stripe API to say, refund this payment. Now, in like real systems that I work with, I wouldn't necessarily refund them directly in this try-catch. Maybe I do something like mark the order as needing a refund, and a human goes and looks at it and says, oh, maybe we can actually charge the customer. Maybe it's OK for us to continue this operation. But for our purposes, let's just assume that we can try-catch and then undo that action through the refund API call. There's still a problem here, though. If you remember in that this first set of slides, there is a database transaction around all of this. Somewhere down like here or there, or maybe over there somewhere, is that action filter that commits the transaction after this request, this controller action succeeds here. And so that still has the possibility of failure. So what I'd want to do is actually pull in that transactional behavior into this set of code so that around this entire API call, I will have that database transaction set of code there so that if the database transaction fails, I can detect that and then go ahead and refund the customer and roll back my transaction. So far, so good? So the question went up here is, what happens if the rollback fails? That's a great question. So let's look at the fourth option. Coordinate. Now that is a valid concern for us to say, what happens when this call fails right here? So we might have some more compensating actions there. Maybe we actually do log it somewhere that is in a highly available format. Eventually, you have to get to the point where we try it as much as we can to capture this operation that's happening in the failure modes, but you can't ever guarantee that everything's going to succeed all the time. I mean, I could try to write the log to disk, and the disk is full, and it doesn't write the log. So like, eventually, you have to kind of be like, well, we did our level best. As long as we actually went through this process, a thought process of designing it and not just threw it over hands, I think that's a valid thing we can do. Our fourth option, coordinate. Now, we already said that these API calls don't support any kind of transactional behavior. That is, I can't put a begin transaction in transaction and have that all just work magically. But I may go ahead and dig in some more to these API calls and say, does it support something like that? That's more, maybe not like a transactional kind of behavior, but do they support some kind of two-phase commit for payments? And it turns out that even the underlying ACH transactions support this kind of concept. Has anyone logged into their bank account and seen a balance and a pending balance? Well, the pending balance is pending transactions that have not yet cleared for the day. And Stripe supports this concept out of the box. It supports it in the term of this, they call it authorization and capture as a two-step payment flow. And the general idea is that I have an initial call to the Stripe API to authorize a charge, which basically is that mortgage agent, the escrow agent, that has taken your money and put it to the side but not quite charged you yet, just like I'm making sure that you have this money. And then sometime in the future, when I actually want to go through the transaction, I capture those charges and finally it's actually out of your account and given to the other person. Now, this one does have business implications from the previous couple steps. In this case, an authorization actually shows up in your bank account as this like money that's not quite there but is there sort of thing. So I'd want to make sure from the business perspective they're okay with this. We're not taking the money quite yet, so the customers may go in and look at their account and see the money is not quite taken out yet. But hopefully, the likelihood of that happening, the authorization succeeding but the capture failing is rather low, and this won't actually ever affect the customer, hopefully. But I still need to put that in front of my clients to make sure it's okay. So what does that look like in our code? More try catches. Surprise, surprise. I would attempt to do all that Stripe transaction, but instead of me charging their payment immediately, instead I post an authorization to their payment. Now, assuming that set of operations succeeds, then I'll have the second step in the auth capture flow, which is to capture their payment and actually take their money. Now, I said we had the question of what happens if that second call fails or the rollback fails. So I still would want to have some kind of logging here to say, oops, I tried to capture the money, but it didn't work. But this is in a little bit better spot than the previous one. The previous one would take their money, but if something fails, refund them. This one will still take their money, but not quite take it all the way. So an administrator could come back in and say, ooh, let's go ahead and go to my transactions that haven't succeeded, and go ahead and capture that money, and I'll let the process then keep going. But this is this kind of weird situation where I could authorize a customer's account and have that money kind of sitting in limbo. So I'd still have to go back to my business to say, which is the one that makes most sense for you? So those are the four options. In terms of which one we would actually do, we'd have to go to our business and talk to them which one makes most sense for us. Next up is SendGrid. SendGrid is an email service provider that provides a nice API interface for me to send emails to customers, templatize them, and all those sort of things as well. So option one, ignore. This one actually may be valid. Do we want our entire business transaction to fail because I can't email someone? Probably not. I'm probably like, well, we took your money. You'll probably get an email sometime in the future, but I'm not going to like not take your money just because I can't email you. Do we really want to tie the uptime and business ability to conduct business to a third-party email service provider? Probably not. So ignore could be a valid option for us. And so it'd just be a simple try catch. Try to call the Stripe API or the SendGrid API, and if SendGrid fails, just log an error, but keep on going. Like, oops, couldn't email you. Oh well, still going to take your money. So I still want to log it at least though, so I can let my my overall administrators know, like, hey, API is down, so probably stop emailing people all the time and wait for that thing to come back up. Option two is to retry. So this is where I'd go again to Google, email service provider SendGrid, retry. No hits, except for a lot of Stack Overflow posts asking if it supports it. Okay, SendGrid item potency. Lots of Stack Overflow questions, but no actual answers. Basically, it comes back to SendGrid explicitly decided not to support any kind of retryable behavior, because what their entire business model is defined through is whenever you call my API, I'm going to send an email as quickly as possible. You call me twice, that's 2 emails. You don't want to call me twice? Don't call me twice. So we don't want to do retry unless it's OK for us to have duplicate emails. Now this is again something I go back to the business to ask and say, hey, we can retry this behavior, but we can't guarantee that they only get that one email. Is that OK? Maybe yes, maybe no, but I need to have the business tell me that. Option 3 is an undo. no matter how much we try, we cannot unsend emails. Even though you have like Outlook Exchange Server has that ability, like sometimes, like people still read the email, and then it gets deleted, and you're like, you tried to send to everyone, didn't you? You actually CC the entire company. So we can't like undo an email. That wouldn't make any sense. Like send a follow-up email like, I'm sorry, I sent you that other email. Maybe that's an option for us. It's like, oops, sorry, apologize, and hopefully they still stick with us as a business. Fourth option is to coordinate. I have no idea what this would mean in terms of emails. SMTP certainly doesn't support it, so we can't. This doesn't exist, so we'll just keep going to the next thing. So our final piece is RabbitMQ. Now, it's important here that I investigate the actual broker we're using, because every kind of message broker is different in the functionality they support. On top of that, every message broker is different in terms of what they recommend that you actually do as well. So RabbitMQ, for example, prides itself on speed. And how do they achieve that speed? By lowering the guarantees. So RabbitMQ, I could, through my options, have that more transactional behavior. That means that everything's going to get a lot slower. So we'll have to make that decision. So the first option could be to ignore. I try to publish an event to the bus onto RabbitMQ, and maybe if it doesn't succeed, I'll go ahead and mark that order as, hey, someone needs to like kick that message down the road because it couldn't work here. Again, I have to go back to the business and say, look, sometimes RabbitMQ, our broker, can go down. So is it OK if we have an administrator page that goes through and finds orders that need to be like poked to be able to send this message? Maybe so, maybe not. The next option is retry. Now this becomes interesting because most message brokers that I work with don't really have any concept of a retry. A retry is like send the message again. And so what does it look like in RabbitMQ? Well, for us, if RabbitMQ fails for whatever reason, we can retry us to send that message, but that doesn't necessarily mean that the first message actually failed. There are cases where I send the message, but I haven't received that acknowledgement from RabbitMQ that actually sent the message. And so I wait for the acknowledgement. I'm like, I didn't get one, so let me go ahead and try it again. But that could still mean that the first message actually went through. I just didn't wait long enough for that acknowledgement to come back. So when looking at this option, it's not just that I'm retrying RabbitMQ. It actually means that I'm retrying everything that RabbitMQ is talking to, whatever downstream brokers this could possibly be. So I'm not even thinking in terms of, does RabbitMQ support any kind of retries? I also have to think about, what about downstream consumers? Can they also support retries for this kind of operation? And if I can't guarantee absolutely that they can handle this kind of retry behavior, then probably this isn't a good option for me. If you want to support this idea of at least once messaging over here, I can send the message at least one time on this side, but only have it delivered and processed by each of these consumers on this side. There's a lot more smarts you have to put in these little arrows that I'll leave off as an exercise to the reader. Smarts. Now, some brokers do support this out of the box. Is anyone here using Azure Service Bus? So many hands. Oh, two hands. So Azure Service Bus does support the idea of retries. And the way they handle it is they'll actually buffer the messages up front for like 30 seconds or so. And so if you send the same message twice within a given amount of time, they can detect that and say, OK, oops, they accidentally sent me this twice, so I'll only actually deliver this to the back end once. But that, again, costs resources because I have to store the messages somewhere. And they don't want to store the messages forever, because that's very expensive, right? Let me look at every single message sent ever and decide if this message has been sent before. Probably not a thing you want to do in your systems. So I only want to do that for a given amount of time. But what happens if I try to retry after 31 seconds? Well, that means duplicate messages in the back end. So option 3, undo. OK, this is another weird one. What does it mean to undo a message? Similar to emails, I can't unsend a message to RabbitMQ. And then if I can't unsend a message, I would have some kind of weird compensating action. on the bus. Like order created event, second message, oops, I'm sorry, order not actually created, my bad, event. Probably not a thing we do in our systems. So compensating message, probably not going to work for us. Now the final option is coordinate. Now some brokers do support a coordination kind of activity. That is, I can, in a kind of a two-phase commit distributed transaction, I can do some kind of transactional behavior over here, and then on my message broker, I'm basically putting my message, but with my finger on it, like, I'm going to put it over here. I'm not going to send it yet. And whenever it thinks it sees, I'm like, OK, you're good to go. Message can go out the door. Some messaging transports support this kind of behavior. MSMQ does. RabbitMQ does not. Again, explicitly, they don't want to support that because it's a very expensive operation for me to be like putting my finger on that message and be like, I'm not going to send it yet, not going to send it. Oh, now it can go. That's actually very expensive to do in a distributed system. So if I try to do that, typically I see an order of magnitude drop in throughput. And for my system, I don't want to do that kind of thing. RabbitMQ doesn't support it anyway, so can't even consider it. And in fact, I'd say almost all the brokers I deal with don't support this kind of distributed transaction, coordinated transaction behavior. So I want to take a step back because we've looked at the different resources we're talking to, all the different options that all the different failure options. And personally, I didn't find any of them to be that good. Like none of the outcomes of any of those different failure modes, I thought that the business was actually going to be OK with. Like maybe they'd be OK with like, I guess we have to do that, but that kind of sucks. So maybe I should rethink the entire process and say, what if instead of me coupling all those 6 little lines of code together, saying they all succeed or all fail, can I avoid these kind of failure modes by perhaps just breaking my process into multiple steps? Now, in most e-commerce systems I work with, they don't couple all these things together. They don't couple the creation of the order with the ability to successfully send an email, with the ability to successfully charge a customer. When I actually worked in a large e-commerce company about 10 years ago or so, we would be measured, our team was measured on its ability to have someone start the checkout process and complete it successfully. In fact, our bonuses were tied to that, like literally. We get bonus based on making sure that everyone that started the checkout process completed it. And anyone that started the checkout process and like pulled out for whatever reason, my little bonus would go down just a little bit. It was very sad. So most e-commerce systems that you use on a daily basis, right? Whenever you get to that checkout flow, it's a completely different user experience than everything else. Amazon, for example, away go all those like buy Kindle, buy Echo, buy all this other junk that we're selling you and collecting all your information from. Instead, when you hit that checkout button, it's like, all right, things getting real. We're going to take your money. So let's get you on this train here. Even have like a little progress bar on the top that's just like, choo-choo, here comes the money train. We're going to take your money. So when I worked in e-commerce, when we were being measured on our ability to make sure customers completed the checkout flow, that meant that we turned off all of our validations. Like literally, if a cat walked across the keyboard, we would still take your order. We turned off any kind of address verification. Like, oh, that's not an actual valid shipping address. Don't care. Give us your information. Oops, I transposed numbers in the credit card I put in. Don't care. Just give us your information. Has anyone had that they turned on in their front-end e-commerce site, the loon check or lun check? I don't know how to pronounce it. Where it's like if you transpose your numbers, it's like, oh, that's not actually a valid credit card number. There's some kind of checksum in that thing. There's nothing that angers a customer more than you telling them they don't know how to type in a credit card number. They're like, I didn't type that right. What am I going to check these 16 numbers and see which one is exactly, like put my credit card up to the screen? No. So we just turned all that validation off and said, just give me your information. And at the end of it, if something goes wrong in back-end processing, what do? We'll call the customer. And that's how we went from like 75% fallout to like 99.9999%. Just turn off all the validation. Now, we have to go back and look at our process and say, what does it mean from a business perspective to break each of these individual steps out as a separate process? Does that even make sense from a business perspective, that we don't do this in the context of a button click, but we do it sometimes later? Now again, this is something we have to go back to our business to evaluate these options and say, based on each of these calls, is it okay if I don't do that right away? What if I do that just a little bit in the future? Does that make sense? From a Stripe perspective, can I take their money now, or can I just take their money later? Well, that may or may not be okay for the business. The business may say, oh, sure, yeah, you can take their money later. Or they may say, you know what, can you actually try to take their money now? And if it doesn't work, then maybe you will we'll have some back-end processing. So we'll do something like trying to post the payment to the end user, but if something fails, then what we'll do is just mark that order as having a payment failed, and then some back-end processing, probably human, would go through and find all the orders that have payment failed, and then go ahead and charge the customer or cancel the order, perhaps. What about SendGrid? Is it okay if we send an email to this person sometime in the future? Do we have to send the email within the context of the button click? Is that customer clicking the button and have their email client over? I'm like, okay, if I don't get an email within like 0.5 seconds, something's wrong. Probably not. Email is an asynchronous messaging system anyway, and we probably don't have an expectation that within the context of like, boop, clicking the button, that we get that email delivered to us right away. So maybe let's not couple our ability to take an order from a customer to our ability to send an email. Now, one interesting thing we looked at here was, is there some way for me to like kind of automatically send this email in the future? When do I actually want to send this email? Is it when the transaction succeeds? Maybe. But in reality, I want to send them your order was successful email when I've actually successfully processed their payment. Only when I've actually taken their money do I want to tell them, thank you for your order. If I haven't taken your money, I'm not thanking you yet. You got to give me the money, then I'll thank you, and not before. Well, it turns out that Stripe has the ability for us, when payments are successful, to do other actions. In this case, via webhooks. So we could use #serverless to have a webhook, so when Stripe successfully processes a payment, they call some other API call that we make in our #serverless world, and then go ahead and call the Stripe API to send that email successfully. Now, in actuality, we still have to evaluate all the failure modes of that webhook call. Like, if my API is down that's receiving the webhook, will Stripe retry that operation? I scrolled down here to the bottom, and I didn't see any documentation about what they do in the case of failure. So if I have no idea what their failure modes are, this may not be a good option for us, if I want to guarantee that email gets sent. And the final one is RabbitMQ. Now, this one's going to be a little bit funny in our ability to try this operation in the future. So the idea is that if RabbitMQ is down, I send the message to it sometime in the future. Well, what does that look like for me to send the message in the future? Well, it could mean that instead of me storing the messages and trying to send the message over here to RabbitMQ, maybe I take those messages and just store them in my business database and says, okay, let me go ahead and put the messages to be sent over here. And if this call fails, then something is going and pulling out these unsent messages out of the database. This is actually known as the outbox pattern. In the outbox pattern, instead of me immediately sending these messages to these downstream providers, I instead store the messages temporarily in my business database, and some other process is taking those unsent messages and sending them downstream. Something like this, don't use this code, this is really bad code, but you get the idea. Code is pulling those unsent messages, taking those messages out of the database, and then forwarding them on to our bus here. Now this introduces more moving parts, right? I have to have this code somewhere, probably in a more resilient format than this, that is polling for unsent messages and forwarding them on. But what this allows me to do is completely eliminate the the RabbitMQ part of the equation out of my process. So if it goes down, I don't care whatsoever. We can just store the messages temporarily in a business database and have something that's kind of cleaning up things behind the scenes. We're still not there yet, though. I took that first step back. I'm going to take yet another step back and say, OK, these are the different failure modes in that single context of the button click. What other possible options are there for us to decouple these 6 lines of code from each other? Right now, there's still 6 lines of code that couple to each other. I've just temporarily removed some of them from the processing. Are there other ways I can handle this overall business transaction? So in these kinds of processes, I start to look at, can I defer these actions to sometime in the future? One or more of them. In the options I've had now, I've kind of taken each individual one by itself. But what I could do is take a look at, instead of me having all of my kind of checkout order processing process directly in that button click handler, can I take that workflow of processing an order and just completely remove it from the front end code altogether and have some kind of back-end asynchronous workflow to actually process your order? Which is what like 95% of e-commerce systems do. They don't do everything in the context of a button click. They take the thing you were trying to do and say, right, we're going to have some kind of back-end processor that will take your information and actually process your order. So again, I have to go back to the business and say, look, we have the possibility of performing this checkout flow instead of within the context of your button click, but to do them offline. For each of these things that we're doing in the button click, can we do these offline instead? And I make that evaluation again. Stripe, is it OK for us to process this offline? The trade-off being that I don't take the money right away, but I maximize the number of people that can make it through the checkout process, minimizing my fallout rate and maximizing my bonus, hopefully, right? Is it OK for us to process that offline? Maybe. Sometimes it's not OK to process your money offline. Sometimes there's a finite resource that I have to make sure that I charge your money right then. Things like airline reservations. Things like concert tickets. These are things that there's a certain amount of these things in existence. And so I really want to make sure I take your money right then, because if I don't, that could potentially mean I oversell and accidentally have too many people buying tickets. Which I guess airlines still do as well, but bastards. So this is something I have to look at the overall business transaction and say, does that even make sense? Is it OK for us to do that? But for sure, the other two things are OK to do offline. Like, I don't really care if I email them right away, nor do I really care if I notify downstream systems right away. RabbitMQ especially, I'm already using asynchronous messaging, so I can just delay that asynchronous messaging just a little bit more. Now we have to be able to kick off this workflow somehow. When I click the button on the page, something has to take that order and then start to do its processing. Now in this case, depending on the platform we're using, there could be a lot of different possibilities for me to handle this. If I'm in Azure, for example, you can use Azure Service Bus and Service Workers to take that message and do something. If I'm in a self-hosted environment, I may be able to use a tool like Hangfire, which allows me to schedule jobs and do some processing. If I'm using something like Python Django, I can use Celery. If I'm using Node, I'm probably using like LeftPad or something, I think, to do stuff. I don't know. So in this case, I'm using Hangfire. Hangfire allows me to have scheduled jobs inside of an ASP.NET application. And so I tell it based on this this cron format down here that I look up once and forget immediately, and have it execute on some recurring job to say, let me go ahead and take those messages that say process the order, and then send them in the future. So it looks something like this now. My initial call to start the order is no longer going to do any of these things behind the scenes. It is literally just taking your information, storing it in a database, and then something behind the scenes is taking those unprocessed orders and then doing some kind of workflow magic behind the scenes to then go to all my different providers and do stuff. So the last thing I want to look at is, what should this workflow do? How should I design this workflow? There are a lot of different patterns for these workflow options behind the scenes. About 3 of them are documented. The rest are just like make it up as you go. So I want to go through those workflow options and say what makes sense for this kind of operation. The first workflow pattern we can look at is one known as a routing slip. In a routing slip, we have a sequence of operations, and the sequence is determined upfront by whatever initiates the process. And as each step executes successfully, it forwards that process to the next step. The message to say do the next thing. So it looks something like this. I'd have each of these in some kind of backend processing with their own message queue. This initial task pushes a message out to the first step. The first step succeeds, forwards the message on to the next step. This one succeeds, and it forwards on to the next step. And this one succeeds, and then we're done. And the initial calling, we'd actually say the individual steps we want to send to. Now this makes sense if I can have some reasonable set of guarantees that all these steps are going to succeed or fail. If I have any kind of alternate processing, like what if this one fails, do something else, then this kind of pattern doesn't really work that great, because now I'm putting failure alternate logic inside each of these steps. Another option is the Saga pattern. A Saga is a way for us to have a long-running business transaction broken up into a series of smaller transactions, and each of the smaller transactions either succeeds or fails. In the case of a failure, I have a series of undo actions that rolls back that overall business transaction into the original state. So the kind of canonical example we see out there is going to be booking a trip. When you book a trip, you're going to book a rental car. Well, maybe not anymore. Maybe we'll just Uber. I don't know. We'll have a hotel, and we'll have a flight. And I can't get everyone on the phone together on a conference call and be like, all right, everybody on the phone, we're going to book a trip. That probably won't go over too well. They'll probably hang up on you. So instead, I break those up into a series of smaller operations and say, first we're going to book the rental car. When that succeeds, we're going to book the hotel. When that succeeds, we're going to book the flight. But if this transaction fails, there's something wrong with my flight, then I'll go ahead and undo the previous operations. This is only possible, though, if I have the ability to undo previous steps. And as we saw what feels like 3 hours ago, we don't have the ability to undo all of our operations. So this one, I can't just take this pattern out of the box. And the final pattern is the process manager pattern, which basically says, well, none of those out-of-the-box ones works for you, so you just have to make it up. This is also known as just like workflow or state machine. This is you're going to design explicitly what the pattern should look like. And so in this case, I have some kind of central process manager that is managing these different operations in the back end. Everyone here has probably already built something like this. You have that table with an isProcess flag, and something's polling it and doing stuff behind the scenes. You've already done something like this. The final little wrinkle in our system is to decide how we want to coordinate these other activities. In this case, there are now 2 more main patterns we can look at: orchestration and choreography. Orchestration means that I am directing the flow of every single step. And choreography means that I am pushing an event out and then waiting for everything to come back and tell me if it succeeds or fails. So in this case, I have to decide for each one of these interactions, do I want to orchestrate that operation, that is direct exactly what it should do, or do I just want to throw out a message and say, when everything's done, come back and let me know? So I would go back to our process and say, based on the process we intend to have, do we need to orchestrate that activity to make sure it happens and know when it succeeds or fails? Or can we just choreograph it and just say, let's let the message be free and then go on with our day? Based on our process coupling, I can look at Stripe as a thing I want to directly orchestrate. I want to know when Stripe succeeds or fails, because only when Stripe succeeds or fails do I want to do these downstream operations. So let's put some control on this operation, and then these other 2 are going to be just sending a message out the door. So our final process will look like this. We have that initial call to the API to create the order and store it in the database. At this point, though, the customer sees the thank you page, and they're going on with their day. Behind the scenes, we're going to have a our back-end task processor that's looking for unprocessed orders and kicking off this back-end process manager. The back-end process manager is going to read the order information out of the database, make that call to Stripe, and based on the call return from Stripe, say, did you succeed or fail? If that Stripe call failed, then maybe we mark the order as needing processed to be payment manually. But we can go ahead and stop the process and say, you know what? If Stripe fails, don't do any other of these downstream operations. If it does succeed, then we go ahead and just call these other things. Now, the final piece I have is I was using RabbitMQ as a means to notify downstream systems. But it turns out SendGrid is another kind of downstream system I can notify. So what I'll do is actually piggyback on top of that initial publishing of that message and have SendGrid just do the exact same thing. Now you might ask, what did we actually go with in our real-world scenario? In our real-world scenario, we ran out of time and budget about 60 slides ago. In actual big e-commerce companies, this is the exact thing that we do behind the scenes. We have just taking your order information up front, but having a back-end process actually do the work. In our example, we went with the refund option, try, catch, refund, because that's all we had time to do. So the moral of the story from all this is, yes, it's super easy to build distributed systems now, and that it's possible. But that doesn't mean that failures can't happen. So when you're building systems that have to talk to each other, think through the possible failure modes and design the overall interaction based on what the business needs and also based on what's actually possible with those other resources. So thank you very much. This has been 6 lines of fail that got multiplied into probably 50 lines of code, but that's OK. Our business is happy, and we get to keep our job. Thank you very much.